Like a lot of kids born in the early 70s, I had the good fortune to be raised by hippies. One of my childhood heroes was Stewart Brand. Stewart is not only one of the originary hippies, he's also one of the first modern environmentalists of the 1960s and 70s. As a young boy, one of my favorite memories is playing cooperative games that Stewart designed as an antidote to the Vietnam War. I'm from a long line of Christian pacifists known as Mennonites, and every August we would go as kids to remember the US government's atomic bombing of Japan by lighting candles and sending them on boats onto Bittersweet Park. As I graduated from high school, throughout college, I brought many delegations to Central America to bring diplomacy, seek peace, and also to support local farmer cooperatives in Guatemala, Central America, Nicaragua. And over time, as I've traveled all around the world, been through many small communities on all the different continents, I've come to appreciate that the young people I interview, they don't want to be stuck in the village. They don't want to spend their whole lives chopping wood and hauling wood. They want to go to the city for opportunity. Most of them do, for education, for work. And what I've realized is that that process of urbanization, of moving to the city, is actually very positive for nature. It allows the natural environment to come back. It allows for the Central African mountain gorillas, for example, an important endangered species, to have the habitat that they need to survive and thrive. And of course, in that process, you've got to go vertical. So even places like Hong Kong, you see, can spare their natural environment around the city, but it requires a huge amount of energy to go up. And so the big challenge of our time is, how do you get plentiful, reliable electricity and energy without destroying the climate? Well, I started out as an anti-nuclear activist, and I quickly got involved in advocating for renewable energy. So at the early part of this century, I helped to start a labor union and environmentalist alliance called the Apollo Alliance. And we pushed for a big investment in clean energy, solar, wind, electric cars. And the investment idea was picked up by President Obama. And during his time in office, he invested about $150 billion to make solar and wind and electric cars much cheaper than they were. And that was having a lot of success, but we were starting to notice some challenges. Some of them you're familiar with. Solar and wind generate electricity about 10 to 30% of the time, so we're dependent on the weather for solar and wind. There were other problems we were noticing, though. Sometimes these sources of electricity generate too much power, and you hear a lot of hype about batteries, but we actually don't have sufficient storage, even in California, where we have a lot of investment, a lot of Silicon Valley types putting money into battery storage technology. So we're trying to figure out, how do you manage all those renewables? And while we were struggling with this problem, around 2005, Stewart Brand came out and he said, we should rethink nuclear power. And this was like a shock to the system. I mean, for me and for all of my friends, I mean, Stewart was one of the first big advocates of solar energy anywhere. In the late 60s and early 70s, he advised the governor of California. But he said, look, we've been trying to do solar for a long time, and at the time, so we have less than 0.5% of our electricity globally comes from solar, about 2% from wind, and the majority comes from nuclear and hydro. And he said, look, despite what you might think, according to the Intergovernmental Panel on Climate Change, nuclear actually produces 4 times less carbon emissions than solar does. And in fact, that's why they recommended in their most recent report that achieving deep cuts in emissions is going to require a more intensive use of renewables, nuclear, and carbon capture and storage. Well, let's take a closer look at Germany. So Germany gets the majority of its electricity and, of course, all of its transportation fuels from fossil fuels. So just the electrical sector, last year Germany got 40% of its electricity from coal, it got 12% from natural gas, 13% from nuclear, 12% from wind, and about 6% from solar. So to go from 18% wind and solar to 100%, you actually have to go beyond that. If you're replacing all of the transportation sector with electric cars, you're looking at something more like 150%. So Germany's done a lot to invest in renewables and to innovate solar and wind, but that's still a pretty steep climb. That's even before you get to the question of storage. So, well, let's take a look at what happened last year. Last year, Germany installed 4% more solar panels, but it generated 3% less electricity from solar. And even when I'm in meetings with energy experts, I'll ask people if they can make a guess as to why that is. And you'd be shocked at how many energy experts have no idea. It just wasn't very sunny last year in Germany. Well, that probably meant, though, then that it was windier, right? Because if it's not as sunny, then maybe there's some more wind, and those two things can balance each other out. In truth, Germany installed 11% more wind turbines in 2016, but it got 2% less electricity from wind. Same story, just not very windy last year. So you might think, well, we just have to do a lot more solar and wind so that in years where there's not a lot of sunlight and wind, that there's more electricity from those energy sources. So Germany's plan is to increase by 50% the amount of electricity Germany gets from solar. That would take you from 40 gigawatts to about 60 gigawatts in 2030. But if you have a year like 2016, that means that you'll still only be getting around 9% of your total electricity from solar. And this is in really the biggest solar country in the world. I mean, Germany is really the powerhouse of renewable electricity. So the obvious response is, well, we'll just put it all in batteries. We hear so much about batteries. You would think that we're just have a huge amount of storage. Well, our staff took a look at the numbers in California, and what we discovered is that we have 23 minutes of electricity storage for California's grid. But to get that 23 minutes requires using every battery in every car and truck in the state, which, as you can imagine, is not super practical if you're trying to get somewhere. And Germany might be a little bit different, but not very different from that. Well, most people are aware that to make this transition towards renewables, Germany has been spending a lot more on electricity. And you can see electricity prices in Germany rose about 50% over the last 10 years. Today, German electricity is about 2 times more expensive than electricity is in France. And you might think, look, that's a small price to pay for dealing with climate change, and I would agree with that. Spending a little bit more money on energy, especially for those of us in the rich world, is a decent thing to do to avert some of the catastrophic possibilities of global warming. But the interesting thing is that when you compare France and Germany in terms of their electricity, France gets 93% of their electricity from clean energy sources, mostly hydro and nuclear. Germany gets just 46%, like about half. And here's the real shocking thing. German carbon emissions have actually been going up since 2009. They have increased over the last 2 years, and they may increase this year as well. And German carbon emissions have declined since the 1990s, but most of that is just due to the fact that after reunification, Germany just took offline all of those inefficient coal plants in East Germany. Most of that reduction is just due to that. And let's take a look at last year. One of the things that really quickly can reduce emissions is switching from coal to natural gas, because natural gas has about half of the carbon intensity of coal. And that would have resulted in a pretty significant reduction in German carbon emissions last year, except for the fact that Germany took offline nuclear, and when it did that, it meant that the emissions actually ended up going up again. Now, there's some questions about, what about the future? So if we just do more solar and wind, won't it kind of all work itself out? Well, one of the biggest challenges to this has come from somebody here in Germany who is not a pro-nuclear person at all, is an energy analyst and economist named Leon Hirth, and what he finds is that that problem I described earlier, where sometimes you have too much wind at certain parts of the day or certain parts of the year, or too much solar and not clear what to do with it, that reduces the economic value of wind and solar. So wind, actually, the value of it reduces 40% once it gets to be 30% of your electricity. And solar, it's even more dramatic. It actually declines by half when it gets to just 15%. So one of the things you hear, though, is that, well, we can do a solar roof like really fast. I mean, solar is fast. You just put it up on one day and you've installed the thing, whereas it takes like 10 years or 5 years, depending on where you are, to build a nuclear plant. And so that makes sense. You'd think, well, if we do solar and wind, you can just go a lot faster. But this was actually studied in an important article for the journal Science last year. One of the authors was James Hansen, the famous climate scientist. And what they found is that even when you combine solar and wind, you just get a lot less clean electricity than when you do nuclear. And that goes for Germany as well as the United States. So what they did is they just compared the 10 years of the most deployment of those two technologies, solar and wind versus nuclear, and it's a pretty stark comparison. Well, I can imagine what you're thinking, because it's what I was sort of thinking. It was like, well, this sounds like I now have to really reconsider my attitudes around nuclear power, but then what about Chernobyl? What about Fukushima? What about all the nuclear waste? Those are really reasonable questions to ask. And in fact, when I was starting to ask them, there were other people that were starting to change their mind. One of the ones who I was most impressed by and was very influential is a British newspaper columnist named George Monbiot. George Monbiot wrote a column shortly after Fukushima where he went through the scientific research on radiation, and what he wrote was, the anti-nuclear movement to which I once belonged has misled the world about the impacts of radiation on human health. I write some pretty harsh things sometimes, but this was a pretty strong column. He was talking to a number of scientists that actually have studied the big accidents. One of them is Jerry Thomas from Imperial College in London. Jerry started something called the Chernobyl Tissue Bank out of her concern for the accident, and totally independent professor of pathology at Imperial College. And I asked her, I said, I'd like to present this, but I'm not a radiation scientist, so can I just steal your slides? I'll put your picture on them, if you let me do that. The first thing she points out is she says, most ionizing radiation, that's the radiation that is potentially harmful that comes from a nuclear accident, most of it's natural. And I was like, well, that sounds all right, you know? I like natural foods, natural radiation sounds good, the hot springs, you know? And she said, no, actually, natural ionizing radiation is just as harmful potentially as artificial radiation. So that's kind of the first thing. The striking thing about it is that the total amount of ionizing radiation we're exposed to from not just Chernobyl and Fukushima, but also all of the atomic bomb testing in the 60s and 70s totals just 0.3% of our exposures. Most of the radiation we're exposed to is just from the Earth or from the atmosphere or from the buildings around us. Let's look at the big one. This is Chernobyl. This is the event that really scared me about nuclear and led me to be an anti-nuclear activist. United Nations has done these very large, comprehensive studies. It's hundreds of scientists around the world that do this research. So the possibility of somebody fudging the data or maybe trying to cover something up is pretty low in that environment, just because there's so many different credible scientists at different universities around the world doing the research. So this is really, I think, was a pivotal moment for me. Chernobyl is the worst nuclear accident we've ever had, and I think there's some people that say it's the worst we could ever have. I don't need to make a statement that strong, but they literally had a nuclear reactor without a containment dome, and it was on fire. Like, it was like just raining radiation around everybody, you know. It was a really terrible accident. And when they start counting bodies, what they come up with is 28 deaths from acute radiation syndrome, 15 deaths over the last 25 years from thyroid cancer, which, as horrible as it sounds, it's actually the best cancer to get because hardly anybody dies from it. It's really treatable. You can take thyroxine, which is a synthetic substitute, get a surgery. In fact, most of the people that died were people that were in remote rural areas that couldn't get the medical treatment they needed. And if you take the 16,000 people that got thyroid cancer from Chernobyl, they estimate 160 of them will die from thyroid cancer. And it's not like they're dying like right now. Like, they'll die of it in old age. And that's not to say that it's okay, but it is to put it in some kind of context. There's no scientific evidence of thyroid cancer outside of those three main countries, Belarus, Ukraine, and Russia. No effect on fertility, malformations, infant mortality. No data for adverse pregnancy outcomes. No evidence for any genetic effects. And I think this last one is the most striking thing. There's no evidence of any increase in cancer, including in the cohort of people who put the fire out and cleaned up afterwards. And I still am surprised by this finding. And so I put the link to the website on there. I don't think you should take my word for it. I think you should go read it, because just reading about Chernobyl for me was a big part of changing my mind about nuclear power. Well, what about Fukushima? This was also the second worst nuclear disaster in history. It was a much smaller release of radiation than Chernobyl. And so what we find is that no deaths from radiation exposure from Fukushima, which is kind of amazing. 1,500 people died being pulled out of nursing homes, being pulled out of hospitals. It was insane. It was a panic. The Japanese government should not have done that. It violated every standard of how you deal with a disaster like that. You're supposed to shelter in place. In fact, by pulling people out of their homes and moving them around outside during that accident, they actually exposed people to more radiation. And of course, you have to put that in comparison to the other things that were going on, like 15 to 20,000 people dying instantly from drowning, pinned under many different technologies, by the way, getting killed by that tsunami. Unlikely to be any increase in thyroid cancer. And the big problems, of course, is just the stress and the fear that you've been contaminated when the evidence suggests that that's not the case at all. They did an interesting study. They brought a bunch of school kids from Paris to Fukushima, and they wore dosimeters. That's what we call the old Geiger counters now. And what they find is that those kids, when they go through the security systems, the radiation would spike. When they'd get on the airplane to fly to Tokyo, the radiation would spike. They go through the French embassy, the radiation would spike. Iwaki is a city, and it didn't get the plume, the radioactive plume. Tomioka did, and it's still a tiny blip compared to just going through the security system. So let's look at some of the basics to put this in context. If you live in a big city like London or Berlin or New York, you're going to increase your mortality risk by 2.8%, just from air pollution alone. If you live with someone who smokes cigarettes, 1.7%. But if you were somebody that cleaned up Chernobyl, got exposed to 250 millisieverts of radiation, 1%. 100 millisieverts, 0.4%. It's just because there just wasn't as much radiation as people think. I mean, the atomic bomb testing in the 60s exposed people to there's so many different measurements for radiation. You can just see a lot more radiation exposure during the A-bomb test than either Chernobyl or Fukushima. I think the key thing here is I'm from the state of Colorado in the United States. We have an annual exposure, just because there's so much granite around us, about 9 millisieverts a year. That's what you would get if you are the 6 million people that live around Chernobyl today. And yet, of course, nobody knows this. Like, here's this really basic science, it's right there on the website, but when you go and do a survey in most countries, this one was done in Russia, only 8% of the population that's surveyed accurately predicts the death toll from Chernobyl, and 0% predicted accurately the death toll from Fukushima. Meanwhile, sitting right before us is 7 million deaths a year from air pollution, and the evidence on particulate matter causing harm has only gotten stronger over the years. So that's why every major medical journal that looks at this is from the British medical journal Lancet, finds that nuclear power is already the safest way to make electricity. And it leads to this really uncomfortable conclusion, one that the climate scientist James Hansen came to recently, which is that nuclear power has actually saved 1.8 million lives. It's not something that you hear very much about. So what about the waste? Well, this is the waste from a nuclear plant in the United States. The thing about the nuclear waste is it's the only waste from electricity production that is safely contained anywhere. All of the other waste goes into the environment, from coal, gas, and then here's sort of an equally uncomfortable conclusion, solar panels. There's no plan to recycle solar panels outside of the EU, meaning that all of us in California, it's just going to join the waste stream. We calculated, well, how much toxic waste, because the panels contain heavy metals and lead and chromium and cadmium. How much toxic waste from solar is there? Well, to get a sense of it, look at how much more materials are required for each different energy source. And when you calculate all the panels that are required to produce the same amount of electricity as nuclear, solar actually produces 300 times more waste than nuclear, very little of it contained, and all of it containing toxic heavy metals. What about the weapons? If I thought there was any chance that more nuclear power would increase the chance of nuclear war, I would be against it. I've always been a pacifist, I still am. Diplomacy is always, almost always, the right solution. Well, people say, well, what about North Korea? Korea proves the point. In order to get nuclear power right now, I mean, it's been this way for 50 years, you have to agree not to get a weapon. That's the deal. South Korea wanted nuclear power. They agreed not to get a weapon. They don't have a weapon. North Korea wanted nuclear power. I think they should have gotten it. We didn't let them have it for a variety of reasons. They got a bomb. They now are testing missiles that can hit Japan. They can hit, soon they'll be able to hit California. So if nuclear energy led to nuclear bombs, it's no evidence for it, not only in Korea, but nowhere. So where does that leave us? Well, I think it leaves us with some uncomfortable ideas. I mean, if Germany hadn't closed its nuclear plants, its emissions would be 43% lower than it is today. And I think if you care about climate change, that's at least something that you have to wrestle with, especially in light of some of these facts about the harms and benefits of different energy sources. And I'll end with a quote from somebody else who changed his mind, and somebody else who was a huge childhood hero for me, and that's Sting. If you're going to tackle global warming, nuclear is the only way you can create massive amounts of power. Thank you very much. Appreciate your listening.